Question 9. Now we've really got to one of the first really meaty questions. It's going to take us a while to do this. We've got a differentiation question, and we've got to find a turning point, and an integration question all in one. We're going to be here for 9 minutes. Part A, we're finding this turning point, we're finding this maximum point here, so let's set off and differentiate the thing. We've got U and we've got V. Product ruling it, so differentiating it gives 1 here, differentiating here gives minus 2 e to the minus 2x. And so dy by dx is crissy-crossy it, these two things times together, plus these two things times together. And of course, at the turning point, this will equal 0. Sorry, scribble there. So what have I got? I've got 0 equals, and I'm going to take out the factor of e to the minus 2x out of this, because there's one of them there, and there's minus 2x's of them there. Clearly, this is never equal 0, because an e to the x would never would. And so we got 1 minus 2x equals 0. So x is equal to a half. X is equal to a half is the x value there. We also need to find out what the y value is. Y equals x e to the minus 2x, so that's a half, e to the minus 2 times a half, e to the minus 1. So the coordinates of that maximum point are half and a half, e to the power of minus 1, or 1 over 2e, of course, there. Part A done. Change colour for part B. Part B now says find the area. And the first thing I'm going to do is I'm going to find out the area underneath the curve. To find out the area underneath the curve, I'm going to integrate x e to the minus 2x dx from 0, because that part there's at 0, up to a. And a, I just discovered, was a half there, so I'll put that in there. And, well, if we used differentiation product rule, then we're going to use integration by parts. So I've got u and dv by dx this time. This differentiates to 1. And we're integrating this one this time, so we're going e to the minus 2x, but not this time. Instead of timesing by minus 2, we're dividing by minus 2. So you get u times v minus the integral of the two things you just worked out. Well, there's another minus there, so I'm going to put plus a half e to the minus 2x dx. Tidying it all up and doing this integral as well. So this integral we're going to divide by 2 again, so I've got minus a quarter e to the minus 2x. The values we're sticking in here are 0 and 1/2. Now it does say do this exact, so I won't just tap it in the calculator for you. We'll see what we get here. So putting the half in, I've got minus a half times by a half times by e to the minus 1 minus a quarter of e to the minus 1. Let's put in the half. Minus, put the 0 in there, we've got 0. And put the 0 in here, we've just got minus a quarter. So here, look, we've got minus a quarter minus another quarter there. So we've got minus a half e to the minus 1 there. Minus a quarter is a quarter. That is what the integral gives. You thought you'd finish there, didn't you? You haven't. Because the integral only gives us the bit under the curve. We want r. And r is going to be this rectangle minus that red bit. And that rectangle, we've already decided, there to there's a half. And how high is it? A half e to the minus 1. So, let's just go look. So I've got a half times by a half e to the minus 1. So that's a quarter e to the minus 1. Take away a quarter minus a half e to the minus 1. Careful with the minuses there. Minus makes it plus. So I've got 3 quarters e to the minus 1. Take away a quarter as my answer. It's exact. 5 minutes exactly if you. So the one thing to add would be that this is pretty standard. We have, other than that bit in green at the end where there's a bit of thinking, what we've just done there is a very standard differentiation and the very first example of integration by parts. If we're going to get a B grade, we want to get most of these 9 marks. I think a B grade is going to get 7 or 8 out of 9 here.